Hello. Hello, good morning, students. Hello.
Good morning, sir.
Good morning.
Good morning. Good morning. The voice is clear? Yes?
Yes, sir. Yes.
Yes, sir.
Okay. Just we will wait for 2 minutes. Let some others also join us. Then we will start. Let us start for today. Yes, we were discussing about, I think last topic we were discussing that was the functions. Yes. Yes, do you remember it was the topic last time we were discussing? Hello?
Functions.
Yes. Let's I repeat it again. What is a function? Just last time we discussed about the relations. Like the relations, it is a rule. It is a rule of function. It is a rule of algebra or arithmetic between the two non-empty subsets, non-empty sets, simply. Rule between the two non-empty sets. Let us see an example, a general example. Daily we face it. Everyone has a looking mirror. When we stand in front of the looking mirror, our image is present in the mirror. Clear? It means these are the two sets. You are standing in the room. It is the one set. It is non-empty. Non-empty means you are standing. Second set is there is a mirror in which your image is appearing. According to the what is the rule? The rule of the physics, law of reflection. Law of reflection applies there. Okay. So you think there are the two persons in the room standing in front of the looking mirror. What do you expect according to the rule of reflection? There will be two images. There will be two images in the mirror. If there are the three persons standing in front of the mirror, then it's obviously clear there will be three images in the mirror. But so here there are the two sets. A set in which the three persons are standing. Second set is in which the three images are being formed. And rule is the law of reflection. Rule is the law of reflection. Let us consider there is a man X, there is a person X, Y and Z, three persons. Now you think there will be the three images and all three will be the different. X has its personal image, Y has its own image, Z has its own image. According to rule of the reflection, it is not possible that X has the two images. It is possible? No. Similarly, Y cannot have the two images or the three images or the three images. Simple rule is every person of the room, every person in the room has an image in the mirror, has an image in the mirror according to the law of reflections. Or in mathematics, if we repeat in this way, every person standing in the room, in three persons we are talking about X, Y, Z, the three persons standing in the room, each person is assigned to a image in the mirror. Then it is a function. It is a called a function. Simple, if you understand from this. No, think over the situation. No, X, Y, Z, we say some other person, say you. Is it possible? If we look in the mirror, there are only images of X, Y, Z, but there is not the image of the fourth person you. Is it possible according to law of reflection? No, it is not possible. If it's not possible, it means it is not a function. It is not a function. The situation, what situation? There are the four persons standing in front of the looking mirror, but only three images are appearing in the mirror. There is no image of the fourth person. It means it is not a function. It means it is not a function. Or again, I repeat, every person in the room standing in front of the mirror must have a particular image. Particular image means image of X is different from the image of the Y. That is the introduction of the function. But let A and B are the two non-empty sets. We call them, let's say it is room, A is the room and B is the looking mirror. No, it's very easy to understand. Okay. Now we assign a rule square. In between A and B. Who are A and B? It is a word of the natural number. Okay. Now see, according to the rule, square. 1 square, 1. 2 square, 4. 3 square, 9. As in the case of the mirror, there are the law of reflection. Here the over rule is square. Is it a function? Yes, it is a function. How? See, every member of A is assigned to some member of B. Every member is assigned to some member of B. Under the rule square. It is called the function. Look, this is the extra member. There is no problem. Think of the condition. If 11 is present here, but here is node 121. 11 square, 121. Then it is not a square. Then it is a not square. Why? Because there is a member 11 which has no image in the B, under the rule square. No one is going to ask you the definition in the exams. Let A and B are the two non-empty sets of function from A to B. So this rule, we call it a function from A to B. It is a rule. It is not a relation. It is a rule that assign to each element x belonging to A exactly one element y belonging to B. Exactly one. See, 1 is assigned to 1. 2 is assigned to 4. 3 is assigned to 9. Okay. Here is the note. We write it in this way. F is such that A from to B. F is a function, or we say rule from A to B. What are the conditions of a function? Every element of A is assigned to an element of B. Yes, we know. Every element of A is assigned to element of B. Same condition. If there are the 3 persons standing in front of the looking mirror, there must be the 3 different images in the looking mirror. Any element of A is assigned to unique element of B. Unique elements means, it means 1 square 1. We cannot attach, it is part of the arrow diagram. It is called arrow diagram. We cannot attach 1 with 4. We cannot attach 2 with 9. Why? 2 square is 4 and 3 square is 9. So every member has a unique image. These are called the images. Every element has a unique image. Then how do we write this example? In this way. 1, 1, 2, 4 and 3, 9. And it is a function. It is a function. Last time also I explained it. First of all, we will check the given sets, they form a function or not. Given rule is a function or a not. It is the first. It is also a formation of a numerical. Simply, you are given this f is equal to 1, 1, 2, 4, 3, 9. Check it is a function or not. Why? It is a formation of the question. We will say yes, it is a function. Why? Every element has a different image in B. Every element of A has unique and the different image in B. See more examples from your booklet. Let A is equal to 1, 2, 3, 4 and B is equal to 1, 4, 9. And here it is given the arrow diagram. We have to check, is it a function or not? Is it a function or not? Let us check out. What is the rule? Rule is square. Rule is square. 1 square, 1. 2 square, 4. 3 square, 9. 4 square, there is no member present. There is no member present. We are not concerned with this. We are concerned with these elements. These elements, they should have an image in B. They should have image in B. Okay. It means it is not a function. We will write f is not a function because 4 is not assigned to any element of B. Or simply we can say 4 has no image in B. 4 has no image in B under the rule. Which is the rule? Square. Which is the rule? Square. Also the work of this numerical is 2 marks. The other is only 1 line, 1 word. Let us see some more concepts of the function. See, we take a set A of the natural numbers, and here is a set B. It is also from the world of natural numbers. And rule is this time cube. Rule is cube. Remember, f is a function from A to B under the rule cube. Now check out, is it in the function? It is arrow diagram. As we write in this arrow diagram. Put the arrow. 1 cube, 1.
Yes, this is
2 cube, 8. 3 cube, 27. 4 cube, 64. Okay. Each element is assigned to some element of B. 1 is assigned to 1, 2 is assigned to 8, 3 is assigned to 27, and 4 is assigned to 64. You cannot assign the 2 with the 64, or 2 with the 27, 4 with the 8. No. Under the rule Q, these arrows are show the direction of the assignment. So it is a function. You will say this 125, we are not concerned with this. We are concerned with the members of this. Okay. If there is member 5, say, if member is say 6, then 216 must be there. 216 must be there. This set is called the domain, remember it. Sometimes they ask in the exam, check it is a function or not, write its domain, codomain and the range. This set is called the domain and this set is called the codomain. These members are called the pre-image. As we in physics we say, if we are standing in front of the mirror, we say it is object. But here we call them pre-image. And these are called the images. These are called the images. These are the names of these elements. Then what is the domain of the function? Domain of the function is, here it is domain 1, 2, 3, 4. We write in this way. Domain of F 1, 2, 3, 4. Codomain. Codomain means 1, 8, 27, 64 and 25. All the members. Don't get with 125. Confused with 125. 125 has 4. There is no 5. There is no 5. It is no problem. It is no problem. It is the codomain. And what is the range? Range is 1, 8, 27 and 64. Then 125 will not be counted into the range. It is rather it is present in the codomain, but it is not in the range. Why? In the range are only 1, 8, 27 and 64. Why? They are the images of some elements. They are the images of some elements. And 125, it has no pre-image. It has no pre-image. So it is not counted into the range, but it is counted into the domains. A very important concept. See, it's clear if someone want to ask. The nature of the topic.
Hello, sir. Actually, the fifth line from the above question, element of B under rule what? Crow? What is this?
Rule square.
Square?
Rule square.
Okay.
Square 4, 3 square 9, 1 square 1, 4 square. There should be 16, but it is not present there. That will check out. It is not a function. It is not a function. It is square.
Okay. Got it.
Let us see some more examples. Here are some characteristics associated with the functions. Each element of A has a unique image in B that we discussed earlier. These are some properties regarding the function. See, it is a new property. More than one element of A can have the same image in B. More than one. Just I told you. 1 is assigned to 1, 1 cannot be assigned to 8. 1 cannot be assigned to 8. But two elements of this A can be assigned to the single element of B. In this case, we cannot assign it. We will see some other example. Okay. More than one element of A can have some image in B. It means more than one pre-image can have the same image, As we discussed the examples above, this second property is not possible in those examples. We will discuss after this. Each element of B need not to be appear the image of A. That we know from the first very example. Let's see 125. It is present here. There is no need its pre-image is present. There is no need its pre-image is present. It may be or it may not be. It may not be. If its pre-image is present, it will be counted in range. If its pre-image is not present, it will be counted in the code. So let us see some more example. So all the examples we are discussing, these are from your booklets or the exams. Let A is equal to 1, 2, 3, 4 and B is equal to 1, 4, 5. And this function is given. It is given. Under what rule? He knows. He knows who gave this question, but it is given, we accept it. Is it a function? Why? So these questions, they carry the 2 marks. See, draw the arrow diagram. It is a very important and to understand the nature of the function. It is a simple way. Draw the arrow diagram. 1, 1, 1, 1. 2, 4, 2, 4. 3, 5, 3, 5. 4, 5, 4, 5. In this arrow diagram, you see a different picture. Just we were discussing about. Here it is someone different. What we see? 3 and 4, they are assigned to single element 5. They are assigned to single element 5. Is it a function? Yes, again it is a function. Because see the second property, more than one element of A can have the same image in B. But if it is reverse, remember, if we say 4 and 5, it is 3 is attached to 4 and 5 both. It is not possible. We will see next example. Note on it. It is not a function. Reason is, it is a function. Every element of A is assigned to some element of B. Let us see some more examples. Let A is equal to A, B, C, D, B is equal to 1, 2, 3, and it is a function A2, B1, C2, D1. Is R a function? Why or why not? The simple way is draw the arrow diagram. Here, A2, simply see A2, B1, draw the arrows, C2, and D. Is it a function? Yes, it is a function. But the situation seems to be very complicated. Here, in A, let us see, A and C have the same image, Similarly, B and D have the same image, 1. Okay. And here the 3, it has no pre-image. All the conditions of functions are satisfied. It is possible. More than 2 images, one pre-image, they have the same image in B. Yes, it is a function. Simply, each element of A is assigned to unique element in B. Let us see this example. A, B, C, D, B, 2, 3, 5. Here it is a function. is f is a function or not? Let us draw a arrow diagram. A to B to A has the image 2, B has the image 2. Yes, it is possible. A 3, no C 3, D 5. It is not a function. Why? See, A and B have the same image 2. Yes. Can anybody check out it? Why it is not a function?
Because element of first set is related with two elements of
Yes.
two elements of first related with one element of second set. Therefore, it is not a
Okay. A, this element A is belongs to the two elements of B. But the definition say it should be assigned to single element. It should be assigned to single element B. But here A is assigned to 2 and A is also assigned to 3. Okay. So it is not a function. So it is not a function. From A, two members from A like A and C, A and C are assigned to 3. It is allowed. It is allowed. But if A has the two images like 2 and 3, it is not allowed. It is not allowed. Again, I repeat, C, A and C have the same image 3. It is allowed. But if A has two images 2 and 3, it is not allowed. It is the main backbone of the definition of the function. So it is not a function. After this, we will discuss the different types of the functions. There are many types of functions, and we here need is only one and onto, one and onto. Again, no one is going to ask us the definition of the one-one correspondence or the onto correspondence or the one-one mapping or the onto mapping. What we need, we want the introduction. What does it mean? What does it mean so that we can apply into the numericals? From these small definitions, we want to conclude the result on a numerical, very important numerical, which mostly carry the 4 marks. But when we attempt that numerical, I will give you the algebraical solution. So you need not to cram these all the things. Only understand them so that in case of the numericals, you can solve it. So simply I told you, whenever there is a numerical, check it is a function or not. It is a very difficult problem for the students. Rather, it is from the basics of the algebra. No, one-one mapping. One-one mapping. One-one mapping means injective. Let us read the definition, then we will understand it. A mapping means a rule, function f from A to B is said to be injective. Injective or one-one means same thing. If the images of distinct elements of A under F are distinct in B, it means if we consider the example as we discussed earlier, if the 3 members X, Y are standing in front of the glass looking mirror, then there will be the only 3 images. But how? The image of X is different, Image of Y is different and image of Z is different. It is the condition of 1-1 mapping. It is a condition of 1-1 correspondence. All the three persons have the different three images. Person is X, its image will be X dash in the mirror. Similarly, if we see the example, let's take a simple, and this one we started from here. Rule is here. It is 1-1 correspondence. It is 1-1 correspondence. See how 1 is assigned to 1, 2 is assigned to 4, 3 is assigned to 9. Every member is assigned to a distinct and the unique element of B. Distinct and the unique element of B, it is a 1-1 correspondence. First of all, it is function, then it is 1-1 correspondence. Let us see some more examples. See, same it is not a function. Check out it. 1, 1, 2, 8, 327, 464. It is also a 1-1 correspondence. Every element of A has a different image in B, has a different image in B. It is 1-1. Now see, it is rather it is a function, but it is not 1-1. It is not 1-1. Clear? Why? 3 and 4, they have the same image 5. They have the same image 5. But the definition of the 1-1 mapping says that 3 and 4 should have the different images in the B. Okay. It is function, but it is not 1-1. But it is not 1-1. As we were discussing this so it is a 1-1 mapping or 1-1 correspondence. No. Let us discuss about the onto. Onto mapping means surjective property. It is called the surjective property. For onto, what we do, consider we are now in the looking mirror. If these elements are X and these are elements are Y, okay? No, we don't discuss from A to B. No, we are going to discuss from B to A. Simply, you imagine the example as we discussed, three persons in front of a looking mirror and there are three images. No, from the inside the mirror, so understand it, try to understand this. From inside the mirror, we select any image. We select any image. Okay. No. That image should have a object outside the mirror. According to the rule of physics, you agree? Every image in the looking mirror must have an object outside the looking mirror. Okay. To give a small change in this statement, we say every image in the glass has at least one object in the room. At least means minimum one. Rather, it is not possible in physics, but in mathematics it is possible. In physics we say one object, one image. But in mathematics we can say if there is one image, it may have one or more than one objects outside the image. If it is so, then we say it is onto function. It is onto function or the surjective function. Simply what we do, we change X into Y. Here we are discussing for X. When we are in B, we shall discuss about the Y. No. See this example. Is it an onto? We know it is a function. Second, it is 1, 1. Is it onto? Let us check out. What the rule says, every image in B, say we pick up 1, it has one object. Yes, it has object 1. No, pick up 4. Square root of 4 is 2 present. Rule is square. When we reverse it, square means square root. No. Square root of 9 is 3. Square root of 9 is 3. It means all the 3 members, they have a object in A. It seems it is a onto, but it is not onto. Why? Remember, it is the word of the natural numbers. In natural, it is natural number word. In natural number, here rather it is not written, but 2 is also present. Imagine, here 2 is present. Or we say 11 is present here, written. If we take the square root of 11, square root of the 11, but square root of 11 cannot leave in this set. It is not the word of root 11. It's a rational number. Root 11 is a irrational number. Clear? But it is a word of the natural numbers. So root 11 cannot live in this set. It means we have one member 11 which has no image, in A. So it is not a onto function. It is not a onto function. Only these definitions no one is going to ask in the exam. But what is the meaning of the definitions? We should know it. This was the definition. And in algebra, how we prove this 1-1 mapping, we write it if x1 is not equal to x2 in A, then f of x1 is not equal to f of x2. Okay. Or reverse, what we say, if f of x1 is equal to f of x2, then x1 must be equal to x2. Implementation is algebraic totally different. It was the definition of onto mapping. It is subjective.
Sir, please explain it. Hello. Please explain the above line what you have written. 1-1.
Which one? Well, that's, I explained it in the example. This one. This one. This is the method of proving in algebra. That the above we were understanding with the help of the journal examples. Okay. And then how to check this mapping in a algebra. In algebra, what we do, we shall discuss the example for this. Reverse of this definition, if f of x1 is equal to f of x2. Listen carefully. In the numerical, what we do to prove the 1-1 mapping, if f of x1 is equal to f of x2, then x1 must be equal to x2. Then x1 must be equal to x2. No, after this we shall discuss about an example. There is some problem in these are the nodes. Okay. It is our final objective. This point is our final objective. It will give us the 4 marks numerical. No one is going to ask for examples. No, sorry, these definitions. You see, a function is bijective if it is both injective and surjective. A function is bijective if it is both injective and surjective. How to prove them in the algebra? That is totally different as we try to understand with the general examples. Second, a function is invertible if it is bijective. Third, all the three lines are attached to each other. If a function is invertible, then its inverse exists. The formation of the numericals is like this. Check the given function is invertible or not. Or sometimes they ask, check the given function is invertible or not. If it is invertible, then find its inverse. It is the most common questions, and it always carries 4 marks. See, it is totally different from the definitions or the above examples. Learn this method, how to prove it, and this method is applied on each and every numerical. Find the inverse of the function f of x. F of x means y is equal to 3x plus 2 if it exists. This is the most common formation of the numerical. Find the inverse of the function if it exists. F from R to R. Where R is a real number. Word of the real number. Try to understand what we do. How to prove 1, 1. See, to find the inverse, the function must be invertible. For invertible, it must be bijective. And for bijective, it must be injective and the surjective. So let us check out 1, 1. What we do? We say let x1, x2 belong to R. Here R is the word of the real number.
What is the last letter of this question? Find the inverse of function f(x) equal to 3x plus 2 if
it exists. If it exists. Exist. E-X-I-S-T.
Okay.
And the function is from R to R. R to R means it is a word of the real numbers. It is a word of the real numbers. So, learn the pattern. You can solve every numerical in this way. Always start with this. Let x1, x2 belong to R. R is the word of the real numbers. Then what is f of x1? Put here x is equal to x1. It is 3x1 plus 2. F of x2, 3x plus 2. Put x is equal to x2. Then I told you in definition, if f of x1 is equal to f of x2, f of x1, put the values, f of x2 is equal to this. 2 cancel with 2, 3 cancel with 3, and x1 is equal to x2. Start with, if f of x1 is equal to f of x2, then x1 must be equal to x2. If it is so, then it is 1, 1. Then it is 1. Simple. What we discussed about in the examples, that was a separate thing. And to calculate in the algebra, it is a totally different. It is the simplest way to check the 1, 1. Again, I repeat, take any two members, x1, x2. You can take also a, b. R is the word of the real numbers. Now, f of x1, here put x is equal to x1, 3x1 plus 2. F of x2, now put here x is equal to x2. According to definition, take f of x1 is equal to x2. We start with this, put the value of x1 and f of x2. Now, calculate it. 2 cancel with 2. No, 3 cancel with 3. We are left with only x1 is equal to x2. If it is x1 is equal to x2, then function is 1, 1. If it is not equal, then f is not 1, 1. F is not 1, 1.
Sir, what is meaning of 1, 1?
1, 1 we discussed about
Okay.
all. That was another concept of understanding with the help of the arrow diagrams. So, here we are going to prove it with in the algebra. It is the same thing. But we do not want to go into detail or in the long run. And I simply explained it how, if it is algebra, how to solve it. If it is arrow diagram, then how to understand that. So x1 is equal to x2, therefore f is 1, 1. 1, 1 means injected. Now 4 on 2. Simple. What to do 4 on 2? Learn this. It is also different from the arrow diagram. Let y belong to R. But why we take y? Because we discuss within the mirror. Y belong to R. Who is y? Y is 3x plus 2. F of x means y. From here, every time, find out x. X is equal to y minus 2 divided by 3. So here, this right side is a real number. Right side is a real number. Why? Y is a real number. Y is a real number. And all this fraction is a real number. Therefore, f is on 2. Simple. Do it. And we write it f is on 2. Now see, f is also 1, 1 and on 2. It means f is invertible. If f is invertible, then f inverse exists. And what is the value of f inverse? F inverse is always this. Why? This value of x, it is always f inverse. There is no new calculation. Everything is a simple one. Totally, it is different from the arrow diagrams. Totally different from the diagram. This value of x, it is also the f inverse or the inverse of the function. Note down it. It's very important in the medical. You can find the similar numericals. Simple rules, I told you. No need to take attention, draw the arrow diagram here, then do this and do this. It is a simple way in the algebra. And the worth of this numerical is always 4 marks. See it.
How f inverse will exist, sir?
If a function is 1, 1 and on 2, if a function is both 1 and on 2, then the conclusion is its inverse exists. Okay.
Can you give me the onto example, because onto is not very clear like 1, 1.
Onto I discuss it. That's you see from the mirror. If the 3 persons are standing in the room, they have the 3 images. They have the 3 images in the looking mirror. See? No. You discuss from inside the mirror. Discuss from inside the mirror. Inside the mirror, you take any image. You are understanding? Then see for that image, outside the mirror, there should be at least one object. It is the condition of onto. Onto means reverse. That is the reverse. We have calculated from here x.
Okay,
We
sir.
have calculated from that.
Small request. Please show the example. It's a small request.
We earlier discussed it.
Yeah, but I can't correlate with those example with this.
Okay. Let's come to the first example that we will discuss. See it.
First example was 1-to-1. I understood that.
It is a function, it is a 1-1, but it is not onto. It is not onto. See it carefully. Carefully. It is a word of the natural number. It is a word of the natural numbers. Okay? No. Check from B. B to A. No. Count from B to A. What is the image of, what is the object of 1? It is 1. Rule was square. If we reverse it, how can we reverse the square? By taking the square root. By taking the square root. Square root of 1, 1. Square root of 4, 2. Square root of 9, 3. Agree?
Okay.
But I say it is not onto. Here thus it appears it is onto. We see every member has its pre-image, but remember it is a word of the natural numbers. Now let us consider this 11. Let us consider this 11. What is the square root of 11? It is square root of 11. But square root 11, it cannot live in this set. Why? Root 11 is a irrational number. But it is the set of the natural numbers. It is the set of the natural numbers. So, like 11 cannot live here. Like 11, 12 cannot live here, under root 12. 13, it is natural numbers. 2, 3, 5, all they are natural numbers. If we write the member 2, under root 2 cannot live here. Under root cannot live here. So there are many elements in B. Many elements of B which have no image in A. Which have no image in A. Okay. That is the onto. That is onto. Clear now?
Got it.
But how to prove in algebra, that is totally different. We follow the different method. It is a very simple one. Because the main objective is we have to convert this, what we are understanding, into the marks. Okay. How can we convert this, what we understood, into the 4 marks? That is a simple way. That is the simple way I told. In algebra, simply do. And this, what is solution in this example? It is a universal for every algebra. Only what is the possible? You will write 6x plus 5, 7x minus 3.
Main thing is that you have written a function of real to real. That means the inverse would be the real.
It's a real number. Okay.
That's why inverse is onto.
Yes. It's also real. Because y belongs to real number. Y.
Above example, what you have stated is actually not real. That's why.
That were natural numbers.
That was
it is a word of the real numbers. In the function, that is the difference. Word of natural numbers or the word of the real numbers.
Good.
Should we move further?
Yes.
No. Here is the new concept. It is again very important. This concept of the function we are discussing. Now, first one we discussed is it a function or not, that carry 2 marks. This one, inverse, that carry 4 marks. Now, if this numerical, it carries 3 to 4 marks. So, in functions, there are many marks available into the exams in comparison to the relations. All the things are very simple. Okay. Let us say, I forgot to upload your question paper. And next time, definitely, I will upload a question paper, and it's some solutions also. Okay, definitely, and I will send you by WhatsApp also. Composition of the two functions. See, here it is algebra. Every student in the school level, they know how to subtract, how to add, how to multiply, how to divide. It is a simple one. Everyone knows. Up to 5th or 6th standard, 7th standard, we all learn it. How to add, how to subtract, how to divide, how to multiply in the algebra. Okay. No, it is a totally different property, that is the composition. It is not multiply, it is the composition. Composition here means image of a image. Okay, that's we were finding in the set A is the element, in the set B it's their image. So, how to find the image of the one set, one function into the other? This sign is for the composition. Let us understand with this example. Leave all the things. Simply start with an example. It's a simple one. You will understand it very quickly. F of x is a function x plus 1. Gx is a function 2x square plus 3. These are the two functions. Find what may be the formation of the questions. Find F composition G. Some write it, we write it F O G. Some read it like fog, but it is not fog. It is F composition G. But sometimes in exams, they do not write this O. In spite of O, they put the dot. They put the dot. However, it is wrong. But what we do? We accept it. If it is F dot G, means it is F composition G. And composition G means not multiply. Find F composition G of X, G composition of X, F composition of F, and G composition G. Only these are the 4 options, not 5th one, not 5th one. Then how to find it? F composition G. See the definition, what we do here, see carefully. F, put the bracket GH, it is the definition. It means image of G in F. Image of G in F. But how to find it? Simply, first of all, definition. F composition Gx is equal to F bracket Gx. No, here, put the value of Gx. Who is Gx? Here it is Gx. 2x square plus 3. F. No. What does it mean? It means in F. See, in F, replace every x by 2x square plus 2. Here you write 2x square plus 3 and this plus 1, that is 2x square plus 4. It is F composition. See, it is clear. Then we will move further. Hello?
सर प्लीज रिपीट सर ये 1 plus 1 ये कहाँ से आ रहा है प्लीज रिपीट
This plus 1.
Going well.
No, see this bracket. It is 2x square plus 3. Who is this? F. Here it is F. Okay. In F, replace this x where it is hand moving. Replace this x with 2x square plus 3. Clear? Right here. 2x square plus 3, then this plus 1, this plus 1. This is 2x square plus 4. No clear?
Okay, sir. Okay.
If it is reverse, G composition F, then G is outside, F is in the bracket. F is in the bracket. No, see. Who is f of x? Check out. It is x plus 1. Put f of x, x plus 1, right? No. What to do? See, G x plus 1. What does it mean? C in G. Here it is a G. It says in G, replace x. Replace x with x plus 1. Replace x with x plus 1. Do it. It is to replace this x with x plus 1 whole square, and C as it is. Solve it. That is the answer. That is the answer. Yes, clear? Hello, are you following the concept?
Yes, sir.
Sir, clear?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
We got it, sir.
Got
I
it, sir.
think this question was in your exam this time. Let me check on I have question paper with me. Yes. The question we are discussing here, there were only two parts. It was FOG and GOF. These two parts, and this work was 4 marks. It was 4 marks numerical. Okay. Next time I will upload the question paper and the many solutions from it.
Thank you.
So these are only the basic things. Then F composition F. F composition F means image of F in F. Image of F in F. See, apply the definition. This F outside, this F of x inside the bracket. No. Put the value of F of x. What is F of x? X plus 1. What does this line means? It means in F, replace every x by x plus 1. Okay. Replace every x by x plus 1. Now here we write in place of x, write x plus 1, then this plus 1, then this plus 1. And answer is x plus 2. Similarly, G composition G. G composition G, first apply the definition G. This first G is outside, Gx in the bracket. Now put the value of Gx. Gx is 2x square plus 3. What does it mean? There the cursor is moving. What is the meaning of this? It means go to G, and in G replace every x with 2x square plus 3. It says this. Then we do it. Here 2 as it is, and x square. X square means 2x square plus 3 whole square. Replace x with 2x square plus 3 plus 3. Leave it as it is. Leave it as it is. Okay. Only these are the 4 types of the questions are possible in this case. He will ask only 2 in the exam. Clear? See, it's also very important one. Yes, clear. Should we move further?
Yes, sir.
Hello, students.
Yes, sir.
Yes, sir.
Yes, sir.
No. Let us take one more example, only for practice. The above example was very important as far as the exams are concerned, but it is only for the practice to the concept. Not so important. F of x is equal to log x. From this way, some new concept you will learn. And gx is equal to e raised to the power x. Sometimes the formation of question is check F composition G is equal to G composition F, or someone read it fog is equal to golf, but that is a wrong statement. But some many students may read it in this way, fog is equal to golf. No problem. Take left hand side, F composition G. Apply the definition, F is outside, Gx in the bracket. No. Who is Gx? Gx is e raised to the power x. Okay. We have put the value of Gx. What does it mean? Where the hand is moving, it means, it says go to F. Yes, go to F. Then change every x to e raised to the power x. Log of x, it means we can write here log of e raised to the power x. Log of e raised to the power x. Now we apply the rule of log. This x comes on the back of the log, and log e is always equal to 1. Remember, log e is always equal to 1, and log 1 is always equal to 0. And that is equal to x. That is equal to x. For simple, it is a rule. Log e raised to the power x is equal to x. Then right hand side, G composition F. G composition F. Apply the definition G, F of x. No, here. Put the value of f of x. F of x is log x. Now, what does it mean where the cursor is moving? It means go to G. Here it is a G. Says change x into log x. Here is the x. Right? In place of x, it is log x. And e raised to the power log x, it is again equal to x. It is again equal to x. Therefore, left hand side is equal to right side. Left hand side is equal to right hand side. Just so simple numerical.
Sir, sometimes I get confused that when we can understand that log base is e, or log base is 2, log base is 10. So
No. We are not discussing about the chapter of the log. Only the algebraic formation of log which can disturb us, that I give you the example. Here we will not use the more than this. That is a totally different topic, log. There are so many bases how to change it. That is a different topic. We are not going to discuss about that. Okay.
So we will assume that log base is actually e here.
Here is a log base is e. There are two types of log. There is a natural log, and one is with the log base 10. Okay. In algebra, which log we use? Here it is base is e. Base is e. The same thing which we discussed here, F composition G, G composition F, how the question is transformed. The concept is same. The nature of question is totally different. The nature of question is totally different, but nothing new. What we discussed earlier, fog, golf, and the inverse of the function. Same. Show that it is also numerical from exam. Most of the numerical which I discuss here, they are either from your booklet or mostly they are from the previous exams. Show that f of x is equal to x cube and gx is equal to x raised to the power 1 by 3 are inverse of one another. So, totally the word is changed, but nothing new. It means what we found here, fog and log. If this is the formation of the numerical, again, what we find? First of all, find FOG, then GOF. If both are equal, then we can say they are inverse of each other. That is it. The concept is same, only the definition is changed. Sometimes I think the writing is fade. It is. Can you read it? What's written here? I think in the scanner it is a problem.
F composition of Gx equal to F Gx.
Yeah. Find out F composition Gx is equal to F of Gx. Here F, what is Gx? Gx is x raised to the power 1 by 3. No. What does it mean? It says go to F. Here we go to F. Here it is x cube. What it says? Change x to x cube. We write here x in place of x cube raised to the power 1 by 3. 3 cancel with 3 and that is equal to x. That is equal to x. Now find G composition F. In question it was not written, but the meaning of this is inverse of one another. The meaning of this statement is F composition G must be equal to G composition F. Now find G composition F. G composition F, again G f of x. What is the value of f of x? X cube. Now in G, it is G, change x to x cube. It is x raised to the power 1 by 3 whole cube. Again it is equal to x. Again equal to x. So we write FOG is equal to GOF. Therefore, F and G are inverse of one another. The working was totally same, only the last line was having the different statement. Note down it. Try to solve it yourself. You can find from your booklet also there are numericals. Let's move further. Yes. It is a new concept. Say the permutation. It is not the permutation combination. We will discuss that about after this. Combinatorics, also an important topic. These are the permutations of the functions. Again, very important topic. It is different formation. Again, whenever there is a numerical present from this topic, that was 4 marks. These are the permutations of function. If we write the function in this form, a1, a2, a3, here are the objects, 3 images, and in the second row we write their images under the rule f of a1, f of a2, f of 3. It is called a permutation of a function. It is called the permutation of a function. Yeah.
The third one is A3, right?
Yeah.
The third column is
Yeah.
A2 written, so I confused.
No, it is a pre-image and its image.
Yeah,
Pre-image,
got
its
that.
image.
Column 3 is A2 and the row is F.
Yes.
A2, A1, A2 and A3 it must be, right?
Yes. A1, A2, A3. F means function. F means function. Just I give you an example.
Roman, it is mentioned AP twice.
There is some problem in voice. Let's see. It is a function. It is a function. No, if we can write in the form of the permutation, remember, draw the bracket. In the first row, you write A. Then in the second row, and below A you write 2. Then B, below write 2. A, below A write 3. Then C, below C write 3. Then D, below D write 5. It is a permutation. It is a permutation of the function. Here, let us see. Say it is a function 1, 2, 3, 4, 5. They are the pre-image. It is a member of set A. It is a member of set A. Here, image of 1 is 3, image of 2 is 4, image of 3 is 2, image of 4 is 1, image of 5 is 5. These are the member of the set A. If we write in this way, it is the permutation. It is the permutation of the function f. Permutation function f. Say it is a G. G is the permutation 1, 2, 3, 4, 5, 2, 4, 1, 5, 3. Okay. See one thing here. The pre-images are always same. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They will be always same. They will be always same. So, here the question is again same. Find the product, find the F composition G and G composition F. Image of a image. I told you what the composition means, image of a image. How to find? Simply say F composition G. We are going to write F composition G. See carefully, try to understand. There is no formula. It's only how to pick the image of a image. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. First line is same, first line is same. No. What to do? You are going to find F composition G. Then from G enter into F. How? Reverse. From G. From G come into F. Like this. We have found the images. Follow it. First member is 1. First member is 1. See here, 1. Image of 1 is 2. Image of 1 is 2. From G, we enter into F. We enter into F. Here it is 2. See, what is the image of 2? It is 4. And we write it here, 4. Clear? Yes? Again, I repeat it.
Repeat again, please.
Okay. See, here it is 1. First member is 1. We have to find F composition G. How we start? We enter into G. It is 1. It is 1. What is the image of 1? 2. Image of 1 is 2. Now from G, go into F. Here it is 2. What is the image of 2? It is 4. And it is our answer. We write it here 4. Yes?
Got it.
No, similarly for the second member. Who is second member? 2. Start from G. What is the image of 2? It is 4. Then enter into the F. Image of 4 is 1. We write here.
Okay, got it.
Then C3. Go to G. Image of 3 is 1. Enter into the F. Image of 1 is 3. And we write here 3. Yeah. After that 4. What is the image of 4? 1. Go to G. G says image of 1 is 2. Image of 1 is 2. And go to F. 2 says image is 4. And its image is 2. It is 4. By mistake it is written 1. Please correct it. Okay. There my hand is moving. It is 4. Okay. Then C5. Here 5. Image of 5 is 3. See, image of 3 is 2. It is 2 answer. No, correct it. It is not 1. It is 4. It is 4. By mistake it is written. No, see, in that side we have used the same rule, composition, with an algebra. I have told you the direct method to find it. Yeah. So what's about GOF? GOF means, no, we will start from F to G. Start from F to G. Again see. First member 1. Here 1. Image of 1 is 3. Enter into G. Image of 3 is 1. That is 1. Then 2. In F, image of 2 is 4. And here it is image of 4 is 5, right? 5. Then member 3. In F, image of 3 is 2. And go to G, image of 2 is 4. Here, right, it is 4. Similarly, for 4, image of 4 in F is 1. Enter into G. 1 image is 2. Right here. Then comes 5. Go to F. Image of 5 is 5. Enter into G. Here G. Image of 5 is 3. And we write here. It is G composition F. It is a permutation compositions.
Sir, please repeat second step.
Which one? Last one.
Second step, please repeat.
This
हेलो सर FOG में जो है हेलो सर FOG
जी ऑफ
फोर का तो सर नहीं FOG बोल रहे हैं सर FOG में फोर यस सर उसमें 4 का तो सर
4 का यहाँ पे 4 आएगा ये रिटन बाय मिस्टेक आई टोल्ड यू
सर 5 आ गया
आएगा सर यहाँ पे
5 आ गया
देखो
4 इमेज 4 की इमेज 5 है और 5 की इमेज F में 5 हो रही है
4 image 5 and 5 image is 5. Sorry, it is 5. ठीक, okay, it is 5.
Okay, yeah.
By mistake it's written. And then
sir, please repeat GOF.
This one.
Yes, sir.
Let's see. It's G composition F. First of all, what is the rule? Always we start from the back side. We enter from F into G. Okay? We enter from F into G. See? Start with this one. First member. Go to F. Here, go to F. Image of 1 is 3. Image is 1 of 3. Then go to G. Image of 3 is 1. Then write here 1. Then write here 1. Clear?
Okay.
Yes.
Okay, sir.
Similarly, second one. See, it is 2. Go to F. Image of 2 is 4. Enter into G. What G says? Image of 4 is 5. Image of 4 is 5. We write here 5.
Okay.
We write here 5.
Okay, sir.
Okay. Similarly, the remaining elements you write to yourself. It's only practice work. There is no formula. It is only the grasping of the eyes. How to grasp the situation.
Sir, can you please explain the right hand side of the composition?
Right hand side, which ones?
The right hand side of this parallel line.
The elaboration of apogee. What she
Yeah.
You want to ask apogee? Apogee? Yes.
Yes, the right side.
The right side with the double line asides between the two solutions.
This it's not for you. Okay, it is not for you. I have explained you in the very short way. It is a long way which I have calculated with. Okay.
Okay, sir.
I have calculated by this right hand side, and I have told you the very simple way, only to grasp the things. Then right here. It's only for me.
Okay, sir.
Clear? These are permutations. These are the very small topics in the functions. Anytime they can be converted into the marks, 2 to 4 marks. Actually, function is a important topic. I will see if something is not in any topic, then in the last lecture, okay, I will give you some extra time, then we will discuss. First we go the main things which according to me, they are very, very important in the exams. Ultimately, our object is that what we are learning, we must get the output. What is our output? We must get them in the exams, and in the exams we must get the numbers also. First objective is that. Here it is an example. You can do it yourself.
Yeah, one question, sir. The above
Yes.
example was of permutations, right? How we can correlate that this is permutation example? That means what is permutation here in the example? Last we have.
Permutation, just I told you. See, it is another example. Permutation of the function. It is a permutation of the function. Okay? In function, how do you write the function? See, these are the members. In the first line, they are the member of the set A. Okay? And in the second line, these are the members of the set B. This we were discussing the arrow diagrams earlier today. Okay, there were the two sets A and B. These are the members of the set A and these are the members of the set B, simply.
Okay.
Please do this example yourself. Note it. I give you 2 or 3 minutes. First do yourself, then you can check your answer. Oh.
Done, sir. But can we know this type of question or this type of permutation or FOG or something else? With this type of questions, how we can correlate with our real time scenario?
No. That is a total different thing. Okay. There are functions which you use in the computer software.
What is the application of this type of questions in our MCA or programming language or something else?
No. What I told you, all these things are used while those students who go into the line of the making the softwares. Here, what is the composition? Simply I told you, listen, if B is image of A, listen me carefully, B is image of A, okay, and C is image of B, then A is C's image of A. That's what we are discussing.
Right.
Okay. Next topic is commentaries. When we discuss about the computer programs, everywhere you need the mathematics. That we say the computer arithmetic. You are from BCA, I think so. It's a computer-oriented numerical techniques or the computer arithmetic. How the computer adds, subtracts, divides, how the computer reads what we give the command. You press the 5 on the keyboard and it is written on the screen. But what is the process between that you press the 5 and it appears on the screen? In such processes, everywhere the mathematics is required. Everywhere mathematics is required. So, the minimum mathematics, we give you the introduction. Why? When you are going to make some software and some concept of the mathematics comes in front of you and you don't know what is it, that is very awkward condition. Okay. The basics you must be known. It must be known to you. When you are going to make some software, it will be also solved with the help of some basics mathematics, arithmetic, discrete mathematics, computer numerical mathematics. Okay. That is the minimum knowledge should be given to a also software student.
Then they further correlate this type of question, this type of theories or examples with their software engineering.
There are not so specified books. There are many books. Okay, in there you can read. So in high discrete mathematics, you are from the computer side. Okay. In detail, if you want to discuss the discrete mathematics, take any book of the MSc mathematics, discrete mathematics. Okay. Then you can read it. You can read it. You will find so many examples here. But it is not easy to understand the discrete mathematics of the MA mathematics without the help of any teacher. Okay. Only from those books we take the small topics, only the basic topics, introductory topics, only which may be helpful for a computer student so that he never finds a problem while he is solving a problem of a software and he is facing any mathematical problem there. Okay. Because there is two type of problems at this time. Every mathematician is not a computer programmer. Got it? And every computer programmer is not a mathematician. This is the main problem. And for a computer, both are necessary. A computer program should be also a good mathematician, or vice versa. We say at this time only that mathematician is successful in his field if he is a good computer operator or a good computer programmer. But it is not possible for a single professor to become the specialized in the both fields. Okay. I am from mathematics. I am mathematician. But still I take the computer mathematics, computer-oriented mathematics, computer arithmetics. Clear? But these things were not in our syllabus when I was studying in the MSc, post-graduation, doing my post-graduation or graduation. By that time, the computer was in school or college time, we never saw the computer. But this time, we are handling it. Why? From the books, we read it regularly, we read it. Because for a mathematician, it is necessary to become a good computer operator or a good computer programmer. Similarly, for a good programmer or a good computer operator, he should be a minimum known to a mathematics. That will give them the knowledge of the mathematics. All things are basics. Next topic is combinatorics, again important. In combinatorics, there are the two topics, permutations and combination. So permutation, combination, again these are from the school level, which will start. But combinatorics, here the topic in our syllabus is, it is a mixture of combinations, permutations, and plus the new concept. More than the school level. But straightforward or directly, if we will start from this level, we will start with the pigeonhole principle or the combination with the repetition. It will be difficult to understand the topic. Also in the exams, the examiners, they keep in mind, they also set the basic questions from the school of the permutations and combinations to make the base for the further knowledge of the combinatorics. We shall discuss it topic-wise. First, I will start it from the very beginning, or you say from the first word of the permutations and the combination, and we will discuss the examples based upon that. Then we will come to the topic on the higher levels. It's a very important topic. but not so difficult. Let me check. What was the 4, 3, 7. From this topic, there were 12 marks numericals in the last exam. And
If you are showing us, we can't see the questions.
Oh no, the next time I will give you the question paper. I want to give the solution also. Okay. Last week I could not find any time, but this week I will solve a few questions for you and this question paper, and I will send it to you on your WhatsApp. You have WhatsApp group in your PCTI? I think so. Yes.
Yeah.
Then
G1 group.
I will show it here also, and I will send it to your WhatsApp numbers also, a PDF. Okay. Yes. And there were 12 marks numerical present from this topic, and all they were the basics, or you can say nothing was from the booklet or higher level booklets, say pigeonhole principle, then degenerations, and the more such topics. Are there some typical topics? They are all simple one. Everyone can follow it. I will start from the zero, okay? From the basic schools. Permutation and combinations. This permutation means arrangements. That permutation was the functions. What is the difference between the permutation and the combination? Permutation means arrangement, and the combination means the selection of the sum arrangement. Let me give you an example. Let's say in a class, the students are sitting wearing the different color of the dresses. Okay. Now, a teacher says the students who are wearing the white shirt, they sit in the front chairs. What will do? The students who are wearing the white dress, they will sit in the front chairs. It is the arrangement. Or you can say those who are in the white dress, they sit in the first chair. Those who are wearing the black shirts, they sit in the last chair. It is the simple arrangement. Arrangement means students are present there. We pointed out some students, those who are wearing the white shirt, and advised them to sit in some particular place among the students. But on the other hand, first was the case of the permutation. On the other hand, if we change our statement, we say the students who are wearing the white shirt, they come out and we will give them a prize. No, this is a different situation. The students who are wearing the white shirts, they will come out from the group. Okay, we have selected, it is a selection of the students who are wearing white shirt. Why? We picked them from the group outside. Then we shall give them the prize or we shall give a treat or a party, anything. This is the selection. It is a combination. It is a combination. In general language, I am explaining you, but maybe the difference between arrangement and the selections. Permutation means arrangement, and combination means the selections. Okay. The rest of things we shall understand with the examples. First, there are a few important formulas based on the permutations. Arrangement of the R objects from the total N objects. R is less than N. If there are the 10 students in a class and we have to arrange the 4 students, R is equal to 4, N is equal to 10. Then the total number of the arrangements, we write it in P, N, comma, or in this way NPR. It is equal to N factorial divided by N minus R factorial. Clear? It is a simple formula for the arrangements of the R objects among the N objects. Second, if N objects are arranged in circle means, let's say the 10 students, they are on the picnic site and say, yes, it's a lunchtime, come and sit in a round circle, or say sit around a round table. It is the different arrangement. If we say them sit in a straight line, it is a different meaning. If we say sit in a circle or sit around a round table, it is a different arrangement. If we say them sit in a round table in a circle, if N objects are arranged in circle, then how many arrangements are there? N minus 1 factorial. N minus 1 factorial. As you told you, if the 10 students are picnic, we say, yes, students, 10 students, it's lunchtime, come and sit in a circle. How many arrangements are there? 10 minus 1 is equal to 9 factorial. That is equal to 9 factorial. If R1, R2, R3, Rn are the different arrangements in the total N objects, if there are the total N objects and there are the different R1, R2, R3 arrangements. Yes, I gave you the example in the class. Some students wearing white shirts, some black, some red, some blue shirts. All they are different. All they are different. We say the students with the white shirt sit on this side, students with the black shirt sit on the back side, students on the red shirt sit on the right hand side. Okay. These are the different arrangements in a total N members. Then total number of arrangements P and R is equal to N factorial divided by R1 factorial, R2 factorial and R3 factorial. These are the main 3 formulas which we use. And addition to this, a very simple rule is FPC. FPC means fundamental principle of counting. In fundamental principle of counting, what we do, we don't need any formula. We count the things on the tips of the fingers. We count the things on the tips of the finger. That is a simple way. We will start from there. That is fundamental principle of the counting. See, this example. How many license plates can be made if each should have 3 letters of English alphabets? Simple. We have to make the license plate. How many license plates can be made if each should have the 3 letters of English alphabet? There are the different conditions. With the letters repeated, and letters not repeated. So we have to make a license plate. And you see the bike number plate of the bikes or the number plate of the cars. Here in the number plate, he says there should be only 3 members, 3 English alphabets. Only there should be 3 English alphabets. Say X, Y, Z, say X, A, T. Any 3 English alphabets. Okay. But you see, sometimes letters are repeated. जैसे A, X, ऐसा भी हो सकता है. X, Y, T, sometimes X, X, Z, or sometimes say C, 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 all the letters are repeated. So there are the 2 conditions. Letters are repeated and the letters are not repeated. So we shall calculate it with the help of the fundamental principle of counting. It means we count the things on the text. Like, draw a rough diagram here. There are the 3 English alphabet, 1, 2 and 3. First case with letters repeated. Letter repeated means one letter may be 2 times or 3 times, like Y, 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 Z, Z, Y, A. How many alphabets are there? 26. See how we count it. We start it from here. It is a number plate, say. The first member. How many possibilities are there? 26, because there are the 26 alphabet. Any alphabet can come here. So, how many options are there? 26 options. Similarly, when we are going to write the second letter of the license plate, how many options are there? Again 26. Why? The letter which is written here, it may also written here because repetition is allowed. Repetition is allowed. Similarly, for the third member, how many options are there? 26. Why? Repetition is allowed. Total alphabets are 26. Any one member from 26 can appear. So what is the result? We write it. First letter can be arranged in 26 ways. Second letter can be arranged in 26 ways. Third letters can be arranged in 26 ways. The total number of the ways is equal to total number of the letters. Let's multiply. It's multiply theorem. Until the process is completed, multiply all the terms. 26 into 26 into 26, that is equal to 17,576. Next time we shall discuss more examples. Yes, it's done. Hello? Hello, students.
Yes, sir.
Yes, sir.
So next time we can discuss. It's only for the introduction, okay?
Okay.
In detail, we will discuss next time.
Sir, what about attendance?
Yes, it's sure. It's okay. होगी अटेंडेंस हो जाती है आपका.
Thank you,
We
sir.
should show our face, right?
Okay, students, we shall discuss the remaining things next time. You can consult your books. Either it is available. I think they are available on internet also. If manually you don't have them, go to the internet, download them, and go through them properly, simultaneously. this topic, discrete mathematics, it is not difficult one, but somehow typical. Sometimes the 10 pages of mathematics, you can learn in within the 10 minutes, and sometimes the 2 lines, they are so typical. Repeatedly we don't follow them. Okay, so that's some nature of the topic is discrete mathematics. To go through it properly, simultaneously, it will help you. Okay, have a good students.
Okay, sir. Thank you.
Thank you, sir.
Thank you, sir. Thank you, sir. Bye.
You're welcome. Bye.
Bye.
Have a good students.
You too, sir.
Thank you, sir.
Yes, sir.
Thank you, sir.
Welcome.